On to page 92 now of lecture 01. There's a challenge down there, the answer's given here, but it says write a program, the length of each number. I think that means to calculate the length of each number actually, so we need to get that corrected. For example, given 8723, it gives 4. In other words, it's counting the number of digits associated with a number which is being entered. Write a program that, given any number, it finds its component digits, e.g. 875, it prints 5, 7 and 8. Okay, so the solution, which has been given to us here, I've put into a .c file. Again, Magic Mike is going to tidy this up for us and get this ready for us to run so we can see what it does.
Okay, let's have a look here. We have a declaration of a variable called number, which is
which we're familiar with. Type a number, so we're doing the scanf operation, and we're putting it at the address of number. We've then got a for loop in there where we're going from 0 to number. Well, number is a variable given to us at runtime.
Yeah, we're looking for a greater than 0. So I equals 0, number is greater than 0, so we're comparing a different value to the iterative value here.
That's right.
Yeah, so we're comparing number, whatever's stored in number.
Yeah.
So you know, we ought to have some error checking there to make sure that the user has inserted some number, but that's for another discussion.
Yeah.
And then we're incrementing I.
Okay.
Okay, and in the printf, what we're doing is we're printing the number. Oh, what's this here?
That's new. That's new.
What this does here, this is an interesting, very powerful operator in C. What we can do down here is we can divide by 10. And what will happen, because this is a whole number, it will drop the remainder. You will not see the remainder, you will just see the whole number.
So number equals number divided by 10.
Yeah. But what this is doing, if we use this key...
hang on. So number equals number divided by 10, and you said it drops the remainder. Why would it drop the remainder
because
at all?
It's an integer.
Because it's an
only
integer.
Storing the whole number. No decimal point will be dropped. It will be lost.
So 10 divided by 3, if 10 is an integer, is 3.
It's 3, yeah.
Not 3.33, because that's a floating point number.
It won't even round it up if it needs to.
Ah.
It won't even round it up. So if you have a calculation that ends up as 4.7, it will become 4, not 5.
Okay.
Yeah, so it just literally cuts it off.
Just cuts it off and forgets what the remainder is.
But what this does, using this percent modifier here, is it stores the remainder of the calculation, the remainder part.
So if number's 10, and I were to percentage divide it by 3, the answer would be 1.
Well, if the number's 10 and you divide it by 3, you'll end up with, in real terms, you'll end up with 3.3333.
That's right.
So what you'd end up in here is 3.
10 percentage 3, and you told me percentage gives me the remainder.
Yeah, percentage gives you the remainder part, isn't it? No, you are correct.
So if I divide 10,
let's try this out.
So yeah, so let's put 10 into number. I need to know this.
Yes, let's try this out. Let's actually try this out. So we've got length of C, and we will just this the best thing to do when you're unsure about a program is to try it out. What is it? What have you called this? Length. Okay, we've got a problem here. So we have forgotten to include our stdio at the top.
Ah, that's probably me on the cut and paste. See how quick that was to debug. That's quite a powerful piece of debugging done there, isn't it? Type a number.
10?
Yeah.
So it's going to give us a 0 and a 1. So it's going backwards in this. So let's just quickly just put a little piece of code in the beginning here to test this out. Okay.
Yeah, I'm confused now.
So let's say we have an int I. No, we'll say we're having an int j, and we're going to say j is equal to 10. Okay. Right, and then we're going to say we're going to print f, and we're going to say two numbers, right? The first number is going to be divide, yeah, and we're going to percent d, and then we're going to mod, and we're going to percent d. And then the first number, we're going to do j divided by 3, yeah? And the second number, we're going to do j modulo 3.
Right, so based on what our discussion so far, what
Yeah.
I would expect that to do is the first one I would expect to give me 3,
Yeah,
and the second one I'd expect to give me 1. Why would I expect that? Because 10 divided by 3, but throw away the
Yeah.
remainder would be 3.23, but I'm going to
Yeah.
throw the remainder away, which is the 1, and the second one is 10 divided by 3. I'm going to throw away
The nine
the 9
and keep the 1.
and I'm going to keep the 1.
Yeah, I think you're spot on there. That's what I think is going to happen too. Perfect.
Perfect, yeah.
So 10 divided by 3,
Yeah.
yeah, is going to end up with 3 with cut off remainder. So it's not 3.3333, it's just 3. And then if we take 10 divided by 3, in that sense, we end up with 9. So 10 minus 9 is equal to 1.
Yep.
So the modular part here
Yep.
is actually going to give us the remainder of that calculation. So
Okay, fine. Let's comment those 3 lines of code out now.
we'll comment it out.
Keep them there because they're a good reminder of what goes on. And let's go back to the code in hand. So we
Okay.
type in our number,
So we type in our number, so we've
which
got
is
our
an
square,
integer, which is
an integer.
important.
So we've got 10 in here, we
Yeah.
store 10 in number. We then go from in I equals 0, number is greater than 0, that's our comparison.
So we're going to be
plus.
stuck in that loop until number
Yeah,
is 0.
greater than 0. Yeah, all the time number is greater than 0.
Yeah,
When,
but
as
if-
soon as it hits 0 or
Right.
less,
0 or less, that loop breaks.
yeah. So what's happening here is we're printing the remainder of the calculation of number divided by 10, but the remainder of that.
Yeah.
Yeah?
Yeah.
Because we're using this percent here. So if our number's 10, then what we're doing is we're taking 10 divided by 10, and our remainder of that is 0.
Mhm.
Because 10 divided by 10 is 1,
Yeah.
but our remainder is 0. So the first line will print 0 in this printf,
Yeah.
and then it will actually divide the value of number by 10.
Yeah.
So, and what will happen then is number will become 0. So number will
No,
become
number will
zero.
become 1.
Number will become 1.
If
So
it were 10.
number will become 1. So then we'll run this loop one more time,
Yeah.
and now we will have a remainder of 1.
Yeah.
Yeah, because 1 divided by 10 is 0, but the remainder will be 1
Yeah.
in integer terms. Yes?
Yeah.
So we would print out 1, and then we would divide number by 10 again.
Yeah.
Yeah. In this case, we'd end up with 0.1.
Yeah. Which
But
would
it's
be-
in integer, so it will drop the
Down to
decimal
0.
bit, and it will end up with 0. So
Yeah.
then it will exit the loop.
Okay, let's try that with a few examples.
Okay. Did I?
Oh, we were still running it with this.
Right, no,
Just
okay.
pick up where we left off.
So I didn't save it.
No, you didn't save it. So
Let's just prove
do that
that.
again.
That's actually, I'm going to now save that, and now we run it again. Now we run it. Now we're good. So if we put 10 in there,
10, yeah.
sure enough, we
And
get
that's
0
what we
and 1.
discussed. Now put 100 in there.
Okay. 0, 0, 1. So if we put something like 1, 2, 3, 4. Sure enough, we get 1, 2, 3, 4.
Now, the original objective, as I recall, was to work out how many digits a number had. Going back to this, and for example, given 8723, it gives 4.
Mm.
So we've kind of got that solution. It's not very
Yeah.
tidy at the
It
moment.
actually has that solution in there, but there's one line of code missing.
Let's just run that again. So I'm going to put in a biggie. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. That's actually an 8-digit number, but sorry, 7-digit number. Can't count.
You've got 2 6s in there, that's right.
So 1, 2, 3, 4, 5, 6, 7, 8. So it would appear the number of characters which are coming out of here are indicative of the number of characters that I've entered. So you're saying there's a line of code missing to work out?
There is. I mean, okay, first of all, we're out of scope, so it's not really answering this question. But first of all, we're out of scope. We need to move this int I into scope. And to do that, what I'm going to do is put that up there. Yeah? So that integer variable now is global. Okay. So what we're saying is if int I, so this I is actually counting every time it does this operation.
Yeah.
So theoretically, it's storing the value that we want it to store of how many digits there are.
How many digits there are? So we just print I.
At the end of this now, all I can do is do a printf and say number of
Digits.
You've
got a typo there, mate.
Number of digits, and then put a %d and then a new line. Okay, and then we print I out here. This might be off by 1 because we're starting at 0.
That's true, but we can always adjust that, can't we?
So let's compile that code and run it, and now we type 1, 2, 3, 4. Number of digits 4.
Look at that.
Look at that. So all I done there was I had to move the declaration of the variable outside of this loop.
Because otherwise you wouldn't have been able to see it outside the loop. Just run that by me again, by the students.
This is a problem with scoping. If I put an int here, yeah, what's happening is this variable is created for the purposes of this block of code
for the for loop, yeah.
As soon as we leave this block of code, this variable will be discarded.
That doesn't exist and you couldn't compile it.
So what I've done is I've moved the scope of that variable to outside of these brackets and inside these main brackets.
So we can see I anywhere inside main.
Anywhere inside these two brackets,
Gotcha.
the scope of I is now visible.
Gotcha.
So I've moved it out of the for loop, I'm incrementing it in the for loop because of this I++, so it's counting the digits, and then once we've exited the loop, I print the result. So now we're actually answering the problem that was posed in the lecture notes that the example code doesn't seem to answer.
No, the solution there, I would argue, isn't a very good solution. I was going to take that printf statement out, but let's just leave it there for completeness. So have we answered the question in there? And there's a second one. So for example, 8723 gives 4. Yes, our program would do that. Write a program that given any number, it finds its component digits, e.g. given 875, it prints 5, 7,
So now we've answered both of those questions in one program.
Yeah.
Both of those problems solved in one program.
Yeah. Just run that again because I'm so proud of that now. Do you get like that? You like a bit of code so much you just can't stop running it over and over again?
Love it.
No?
I love it. When it's neat and tidy like that, and it exactly answers the problem in that's been issued, it's great.
Look at that. Look at that. And it's printed out the digits I entered as well. Absolutely marvellous.